All right, 10.3, inscribed angles. So we kind of talked about central angles, right? So the central angle has the vertex on the center of the circle, and its intercepted arc is equal to the measure of the central angle, okay? Inscribed angles are a little bit different from that. So an inscribed angle is going to have the vertex on the circle, and then the sides of the angle are going to be chords. Right, so chords have 2 points on the circle. Okay, so looking at a circle, right? Here's your circle. Pretend it's perfectly round. This would be an inscribed angle because this is the vertex and the sides here are chords of the circle. Okay? The arc that is on the inside of the interior, or is on the interior of the inscribed arc or angle, is the intercepted arc. So we're talking about this part right here. It would be like if the angle was collapsing on itself, the intercepted arc would be crushed when the angle collapses. Okay? So a couple theorems about them, right? Or just one, I think, for now. Yeah, let's do this. So theorem 1018, 10.8, not 1018, that would be a lot, okay, is the measure of the angle and the arc. Okay, and it tells us, different than the central angle, that if an angle is inscribed, the measure of the angle, so here is A, D, B, is going to be half the measure of the arc, okay? And here's the center. So angle is half the arc for an inscribed angle, okay? So here's a circle, here is the center of the circle, and here is your arc and your angle, okay? It goes right here to the same point. A, B, C, we have a point D outside here. So we're looking for the measure of arc ADC. We're told this, okay? So arc ADC is here. That's like if I extended the sides of my angle, okay? It's the intercepted arc. And theorem 10.8 tells us the angle is half the arc, okay? Well, you know, this is a 90-degree angle, so the measure of angle ABC is 1/2 the measure of arc ADC. So the arc is going to be twice the measure of the angle, and the angle is 90 degrees. So the measure of the arc is 180 degrees. It's also a semicircle. Okay? So another one here, right? Here is your intercepted arc. This is angle ABC. We're told that it is 70 degrees. So the measure of angle ABC is 1/2 the measure of arc AC, because that's our intercepted arc. So the measure of the arc is twice the measure of the angle. You're told the angle is 70 degrees. So the measure of the arc is twice that, which is 140 degrees. Okay? Intercepted arc, right? Inscribed angle is half of the arc. So if you know the arc, to get the angle, you divide by 2. So let's look at something a little bit more complicated than just one angle. Here is our circle. Here's A, B, AC, AD, and then B goes to E, and C goes to E, and E goes to D. I think that's, yeah. And you're told right here this is 90 degrees. So arc AE is 90 degrees. So we want to find the measure of angle ABE. Okay, well let's see where angle ABE is. So here's A to B to E. So the angle is half the arc. So that would be half of 90 degrees, which is 45 degrees. That's the measure of angle ABE. Okay, next we're asked for the measure of angle ACE. So here is A, here is C, and E. So the angle is half the arc. The same arc, so the measure of angle ACE is also 45 degrees. Okay, and we're asked for the measure of angle ADE. So the angle is half the arc. Right here is ADE. So it is also 45 degrees. Because they are saying they are all intersecting the same arc. Okay? So they all have the same measure for their angle. So intercepted arcs, the inscribed angle is half the arc. Inscribed angles are vertex on the circle, and the sides make up chords of the circle. Okay, that kind of gives us our next theorem. So it tells us theorem 10.9 that if you have two inscribed angles, and they intercept the same arc, then the angles are congruent. Kind of what we just saw, right? So here is our circle. Here is A or C, A, D. Okay? And we have angle, nope, I drew that wrong, sorry. We want angle C. So we're going from A to C to D. Okay, so that's the one angle we're looking at. And angle, I will get this right, I promise. So angle ACB and angle ADB. Okay, so the angle C is going to be congruent to angle D because the arc, they both intersect arc AB. So they have to be congruent angles. Okay? So if we have our circle, same type of look here to here, like this, okay? This is A, B, C, and D, and that the measure of angle B is 44 degrees. We want to find the measure of angle C. Okay, well, angle B is created right here. So it's intercepting arc AC, or AD, sorry. And angle C is here, intercepting the same arc, so these two angles have to be congruent. So they both equal 44 degrees. Okay? All right, then you take your circle, and inside it you draw a polygon. And the vertices of the polygon are on your circle. Remember, a polygon just has many sides. So here's my circle. Here is a polygon. Okay? Each vertex is on our circle. Here's the center of our circle. Okay? Then we say this polygon is inscribed in the circle, and we can say that the circle is circumscribed about the polygon. Okay, so the polygon is inside the circle is around the polygon. Okay, then with that we can say that if you have a right triangle inscribed in a circle, then the diameter, or the hypotenuse, is the diameter. And the converse of that is that if one side of a triangle is a diameter of an inscribed triangle, then the triangle is a right triangle. And the hypotenuse is opposite, or the angle opposite the diameter is your right angle. So it's saying here is your circle. If you know this is a right triangle, then you can say that this is a diameter. If you know this is a diameter, you can say it's a right triangle. Okay, that's the converse of it as well. The next theorem, the last theorem for 10.3, tells us that if you have a quadrilateral inscribed in a circle, can only happen if and only if, that's what the double F is, its opposite angles are supplementary. Okay, I'm going to just put my circle up here for space, but it's going with theorem 1011. Okay, so quadrilateral means four sides. Here's a four-sided figure. We're going to say this is D, E, F, and G, and here's the center. Okay, opposite angles, so D and F. So we're going to say angle D plus F is 180, and C plus G, or E plus G, is 180. What it means to be supplementary. Okay, if it's true, then the quadrilateral is inscribed in the circle. If the quadrilateral is inscribed, then you know opposite angles are supplementary. All right, so a couple of examples, and that's 10.3 for you. Okay, so here is our circle, and here is a triangle inscribed in the circle. We're going to call this triangle BCA. Here is the center of our circle. We're saying angle C is 3x degrees. We want to find the value for x, okay? Well, AB is a diameter. So triangle ABC is right. And angle C is the 90-degree angle. So we know that that's 90 degrees. It's also equal to 3x. We divide by 3. We get x is 30. Okay. And one more. Here is our circle. We have a quadrilateral inscribed in the circle. And this is quadrilateral A, B, C, and D. We know A is 10y, B is 19y, C is 40x, and D is 22x. Okay, we're asked to find the value for x and y, right? So theorem 1011 tells us that a quadrilateral is inscribed if and only if opposite angles are supplementary. So 10y plus 40x has to be 180 because that's one pair of supplementary angles. And 19y plus 22x has to be 180. Okay, so we have a system now. This you have to go back to Algebra 1 to review solving systems, okay? I'm going to divide this first equation by 4. And I'm going to get, no, not by 4, I'm sorry, by 10. I'm going to get y plus 4x equals 18. And then I'm going to use substitution and get that y equals negative 4x plus 18. And then I'm going to substitute that into my second equation for y. And I'll get 19 times negative 4x plus 18 plus 22x equals 180. And then I'm going to solve this for x. And I distribute the 19. And I get x equals 3. Then you have to go back and take x equaling 3 and substitute it in here for y. And we get y equals negative 4 times 3 plus 18. And so y equals 6. And then you can find all of the angle measures. Okay, this is also in your notes. I know it's hard to see it all. Okay, so that is lesson 10.3.